physicists. Today we'll be learning about 1D motion. The first terms we're going to learn about are scalar and vector. Something that is scalar is a quantity described with magnitude only, such as distance or speed. A vector is a quantity described with magnitude and direction, such as displacement, velocity, and acceleration.
We're going to learn about the terms time, distance, and displacement. Time, represented with a lowercase t, is in seconds. Distance, represented with a lowercase x, it's the length traveled. Displacement, it's delta x, and it is distance from the starting point.
Alright, so average velocity is represented with the symbol of a v with a line over it. And you find it by doing v, which is the final velocity, plus the initial velocity v naught over 2. Instantaneous velocity, represented with just v, is the velocity at a certain point in time. And you do that by taking the limit as t goes to 0 of the change in x over the change in t.
This is gravity. This is acceleration, which is a lowercase a, which is v minus v naught all over the change of t, which is the change in over time. Gravity is a lowercase g, which is 9.81 meters per second squared downwards, which is the acceleration of an object towards the center of the earth.
So these are all the motion equations that are part of this unit. These are really important. They're basically the bread and butter of 1D motion. You're going to probably use them in every single problem that you have. So just to go through them again, you got your average acceleration and then your average velocity and acceleration, and then you got v equals at plus v naught. Over here you have v squared is equal to v naught squared plus 2a delta x, and then you have delta x equals 1/2 at squared plus v naught t. And another way to write the average velocity is the delta x over delta t.
Okay, so one type of 1D problem is a three-phase problem, in which usually there's a car or a cart moving, let's say, in this direction. So for example, in the first phase, this is a typical setup. Acceleration will be greater than 0. It's accelerating in this direction. In the second phase, acceleration equals 0. It's constant velocity. In third phase, acceleration is less than 0. It's accelerating in that direction, slowing down. So maybe a car is moving this way, it's going constant, and then it brakes. So they'll give you, in each phase, they'll give you 2 to 3, either x or velocity or acceleration, and you'll have to find out the third one in each one of those.
And time.
So we're going to do the objects throwing straight out problems, which kind of look like this all the time. The ball, or objects, whatever, is going to start and end at the same distance. At the top, the velocity is always going to be 0. The time to get to the top is going to be the same as the time to get back to the bottom. And the acceleration is always 9.81 meters per second squared straight down towards the ground. And that's about it.
So for ball drop problems, you're going to use your motion equations to solve for the distance, time, or velocity of an object dropped from a certain height. And so your acceleration is always going to be 9.81 meters per second squared, going downwards, and your height's going to be variant depending on how tall the building is, and that'll affect your velocity and your time.